Hi everyone. In this video we're going to practice more graphing with rational functions. And I promised you one with the slant asymptote, so that's going to happen in this one. So let's take a look. We always start with factoring the numerator and the denominator. Now my denominator does not need to be factored. The numerator can be factored into x minus 5 and x plus 1. Now here's an interesting thing. If, hypothetically, this came out to x minus 3 and this was an x minus 3, what would happen is, hypothetically, this could reduce. And the graph of this function would look like a straight line. It would look like the line x plus 1. So it would cross at positive 1, it would have a slope of 1 and go in both directions like this. But it would have a hole right at the 0 of the function that reduced. So if you reduce out the x minus 3, hypothetically, if this was a minus 3, okay, the 0 of that would be at positive 3. So there would be an actual hole in your graph right at positive 3 because that's the thing that reduced out. So your graph would look like a linear function and it would have a hole right there. Okay, that's just a side note. But back to step 1 in this function. Okay, so we factored. We would find the 0 of the numerator. Okay, those are our x-intercepts. The zeros of the numerator are positive 5 and negative 1. I can evaluate for x equals 0 to find the y-intercepts. Okay, when I put in x equals 0, I would get negative 5 over negative 3, so that's 5/3. Okay, and then I would find the vertical asymptotes next. So these are the zeros of our denominator. So my vertical asymptotes, well, there's only one, and it's just at positive 3. The horizontal asymptotes, again, I'm going to go through these things. So horizontal asymptotes, I would check to see if I have the same degree. I do not. The numerator has the greater degree. The denominator is 1, degree 1. This is degree 2, so there are none. No horizontal asymptotes. Okay, now for the slant asymptote, the degree of the numerator is 1 more than the degree of the denominator. So I'm going to use some polynomial long division on this. So I will take this x squared minus 4x minus 5, and I'm going to divide by my denominator of x minus 3. So I have to multiply by x here to get these, to multiply to get this. So I get x squared minus 3x. I have to subtract. So I get negative x there and minus 5. So then I'll multiply by negative 1. So that negative 1 times x will equal this. Okay, and then I have to subtract. And I get negative 8 as my remainder. Now, when you're finding your slant asymptote, the remainder does not matter at all. We ignore it. What's really important is this divisor up here. So we have y equals that. And I said divisor, I did mean quotient. This is my slant asymptote. Okay, so I found the slant asymptote. Now I'm going to put all of this on a graph, and I'll find more points. So my x-intercept is 5 and negative 1. The y-intercept is 5/3. 5/3 is 1 and 2/3. So 1 and 2/3 is right here or so. Okay, the vertical asymptote is 3. So 3 would be right here. Okay, there it is. And my slant asymptote is y equals x minus 1. So again, I have to graph this function. The negative 1 is the y-intercept, and the slope is positive 1. So it's going in this direction, like that. Now remember, this is an asymptote. It's not actually part of my graph, although I do show it as a dotted line on my graph so that anyone looking at my graph will know that there is a slant asymptote right there. So those are my asymptotes. Now, I'm pretty much done with all of that. So all I need to do is find a few extra points and put them on, and that will help me with my graph. So I'm going to put in 1. If I put in 1, I get, let's see, 4. Okay, so I'll graph the point 1, 1, 2, 3, 4. There it is. I'll put in -2. And I get out -1 2/5. Okay, so -2 got me -1 2/5. It's a little less than 1.5. Okay, if I put in, I'm running out of room up there, -4, let's go this way, I will get -3 6/7, which is basically like almost -4. So -1, 2, 3, 4, -1, 2, 3, and almost 4 would be like that. Okay, so notice I picked a bunch of points from over here to get this shape really well. Okay, then I'll pick a few more points over here to get that shape, and that will be my graph. So basically it's doing this, it's coming this way, and doing that. Now the points, there is no rule about how to pick the points. You want to get enough points to show that you've really investigated the shape of your graph. You don't want to be here forever though. So you notice I skipped over this value here. You can get that point, you can choose not to get that point. But just make sure you're evaluating your function for x values and getting more points. Really important. Don't just look at the calculator graph, because when you sketch it, it's going to be off. Get points. Okay, so I need a few points over here. I'm going to put in a 4. If I put in 4, I get out -5. So 1, 2, 3, 4, -1, 2, 3, 4, 5. I have something on 5. So I'm going to go with, I'm going to skip over 6 and I'm going to just go ahead and do 7. If I put in a 7, I get 4. So 7, 1, 2, 3, 4. Now I can get more points if I want. Notice I've gotten pretty close to this asymptote. I can tell it's headed downward like this. I can tell it's going upward like this. And I can pretty much tell it's going to head in that direction. If you wanted to, you could get a few more points, but this is sufficient to see the shape of the graph. Okay, so now let's talk about domain, range, and behavior near a vertical asymptote and end behavior. So, in our domain, let's start there. I'm allowed to put in any x value I want except this vertical asymptote value, which was 3, so x does not equal 3. For my range, I did not have any horizontal asymptotes. Notice, if I look at this part of the function, it's going down forever, and it's going to continue to head upward forever. That makes it look like the range is all real numbers. If you wanted to investigate by this part of your graph, you'd see it will go down forever in this direction, and it will still go up forever in that direction. So it doesn't matter which part of the graph I pick, my range is still going to be all real numbers. Next, let's talk about behavior near our vertical asymptote. So as x approaches the value of 3 from the negative direction, that means it's from this side, the function is headed up forever. So that's y is approaching positive infinity. And as x approaches 3 from the positive side, meaning from this side, the graph is headed downward forever. So y is approaching negative infinity. Okay, that's my only vertical asymptote. I don't need to do the slant asymptote. That one is usually not done as well, just like horizontal asymptotes. But I should do end behavior. So as x gets really, really big, as x approaches positive infinity, my function is approaching. So as I go in this direction, the function's going to continue to head up. So this is positive infinity again. And as x approaches negative infinity, as I go in this direction, my graph is headed downward. So y is approaching negative infinity, and that's my end behavior. Okay, that's it for this graph. Let me know if you have any questions or if you want to see any more examples on this.